So good morning. Today we have agenda regarding Wi-Fi system problems. There are two problems. Yesterday we stopped at it. One problem is the hidden node problem. The second one is exposed node problem. Solution to hidden node problem and uh, exposed node problem. We also discuss the frame format of 802.11, that is Wi-Fi. So to start with, you observe, see, whenever you take, Wi-Fi system, any Wi-Fi router has a radius on which it can transmit the signals. So if A is transmitting its signals, so A can transmit up to 1 meter. So just imagine it is transmitting. So A can transmit beyond 1 meter. A cannot transmit. Same way, C also can transmit 1 meter, up to 1 meter. So C can transmit. So literally speaking, B can see A transmission. B can also see the C's transmission. So there are three, Wi-Fi nodes available. So there is wireless nodes, A, B, C. A has its own range, B has its own range. A and C cannot see directly. They cannot see. They cannot see who is transmitting. But B can see if A is transmitting. B can also understand. Oh, there is a transmission, and B can also understand C because B resides inside C's range, and B also resides inside A's range. So that is the question. That is the situation. Consider a situation depicted in the figure. Yes, this is the figure where A and C are both within the range of B, but not each other. Okay, so B can reach A and C, but A cannot reach C. C cannot reach A. Okay, so they are, they cannot reach. And suppose both A and C wants to communicate to B. So each will send a frame to B. So once each simultaneously A and C both sends the frame to B, so what happens? So there is a chance of collision because A cannot see C node, C cannot see A node transmitting. So by chance, if they both transmit node to frame to station B, so what happens? There is a chance of collision. So at a time, only one should transmit. If both transmits, there is a collision. Okay. A and C are unaware of each other since their signals do not carry that far. So these two frames collide with each other at B, but unlike an Ethernet, uh, either A or C is aware of the collision. They will not understand there is a collision at all because it is happening in the air. And A and C are said to be hidden nodes. So A cannot see the node C. Node C cannot see node A. So without seeing them, they have a common you know node coming in their range, and if they transmit, what happens? There is a chance of collision. So this is a problem, hidden node problem. This is what you call it as hidden node problem. So A is hidden to C, C is hidden to A because they don't come under direct range. They never come under range. In their range, only B is there. If both transmits to B at the same time, so collision happens. And they'll never even come to know there is a collision happening. This is what you call it as hidden node problem. And next one is exposed node. Exposed node. So look at the situation. A can see station B, station C, but they cannot see station D, say station D. Station D is not seen from A. So this is a situation. This is a situation. Look at that. A in A's range, station B is there, station C is there. So that is situation, and D doesn't come inside station A. So it is out of station D. Okay, D is out of A's range, but D D station is present inside C station range. That is very, very important. B and C, B and C are, are present inside A, but D is present inside C. D is present inside C, and B is also present inside C. So this is the concept that you should understand. So the second problem, what we are about to talk is exposed node. In exposed node, what happens? Observe the diagram where each of the four nodes is available to send or receive the signals that reach just the node to its immediate left or right. Okay, left and right. Okay. So if A is transmitting, B and C will not transmit, because in the range of A, B and C are available, so they will never transmit. Okay, they just keep quiet. When C is transmitting, of course, it will come to know, B and D will come to know. So B and D will not transmit, but A will not come in the range of C. So if A may transmit, the collision can happen. So it is the uh, situation. It is a situation. Now, for example, if B can exchange frame with A or C, A and C. So B can exchange data with A and C, same way. Okay, but it cannot exchange data, but it cannot reach to D, while C can reach B and D. So C can you know transmit B and D, but cannot transmit to A. So this is cannot transmit directly to A. So that is the concept. Suppose, imagine there is a situation. If C is transmitting to D and B wants to transmit data to A. So if B is transmitting data to A, what happens? It is in the different direction. B is transmitting data to A, it is in the different direction. Then automatically C will understand, oh, B is transmitting, I have to wait. Just it will wait. But it is not for A. It is for A, it is not for C. So even though B is transmitting to A, C senses, oh, there is a transmission from B. So what happens? C will keep quiet, even though it has data to send to D, which is in the other direction. So this is another problem. If one station is transmitting, other station will certainly keep quiet. This is what you call it as exposed node problem. Since it is exposed to B, C is exposed to B, and if B is transmitting to other node, C will not transmit. C will not transmit. This is another problem. You see the same thing. Suppose B is sending data to A, and node C is aware of this communication, because it hears B's transmission. And what happens? Since B is transmitting to A, simply keep quiet. Of course, the signals of B will not reach C because it is towards A. It is towards A. So it will never send. So since B is transmitting, there is a vibration in the air. So C also imagine, so there is a transmission. It may come to me. So it will simply keep quiet. It will never transmit. So this is another problem with respect to uh, exposed node. Since C is exposed to B unnecessarily, it has to wait for transmission to get over from B. So which is another problem. Okay, you can see the same thing. It would be a mistake. However, for a C to conclude, it cannot transmit to anyone just because it is hearing the B's transmission. It is just hearing the transmission of B, so it cannot transmit. So this is since it is an exposed node, C is exposed to B, so automatically what happens? C has to keep quiet. So this is another problem that I can see. For example, suppose C wants to transmit to node D. This is not the problem, since C's transmission to D will not interference in A's ability to receive from B. It will never, okay, waves from B to A will never interfere with respect to C to D. But still C has to wait until B finishes. This is another problem because C is exposed to B. So this is exposed problem. This is exposed problem. So uh, one is hidden node problem, where without their knowledge, if A and C sends the data to B, suddenly what happens? Collision happens. That is one problem. Second problem is if B is transmitting, A cannot transmit, even though B is transmitting to A and C is transmitting to C. So they cannot transmit because there is a illusion that there might be a collision. So there might be a collision. There is actually collision will not happen because C is sending data to D, A is sending data to A, B is sending data to A. So there will not be any collision. But still, since A and B are exposed to each other, they will just simply keep quiet, stating, okay, let B finishes, then C will transmit. So that is the problem with respect to exposed node problem. Okay. So what is the solution to hidden node problem and exposed node problem? So 802.11, that is the standard protocol, addresses these problems by using CSMA CA. So collisions, carrier sense multi-axis with collision detection, collision avoidance, where CA stands for collision avoidance. In contrast to this, the collision detection, so CSMA CD, it is used in Ethernet. So CSMA CA is used in 802.11. So in 802.11, they have a concept called collision avoidance. So they will just avoid the collision. So Ethernet collision detection will be working in wireless Wi-Fi. Collision avoidance protocol is working. And in the carrier sense part, seems simple enough. Before sending the packet, the transmitter checks if it can hear any other transmission. If not, it sends. That means if suppose system A is transmitting to system B, just imagine. So system A first checks in the air, is there anybody transmitting? If nobody is transmitting, so it will transmit. So it will send. So there is a concept. So, however, because of there is a problem with hidden terminal, so just waiting for the absence of the signal from other transmission, does not guarantee that there is a collision. So if there is no signal inside its range, it is does not mean that it is a collision free. So since there is a hidden frame problem, hidden node problem, collision may occur because B may be in the other region. So hidden node problem. So what happens with this perspective of the hidden node problem? What uh, your sender will do is, first sender will send a special mechanism. It will send a different frame. So special frame, we call it as RTS, ready to send. So ready to send, it will send a ready to send message. Once the receiver receives, okay, if it is free, if nobody is transmitting, so then it will send a message clear to send. That means CTS, once it is received back to the sender, so what happens, transmission will happen. So in this way we can avoid the collision. If suppose uh, for a station B, if C is already transmitting, which A will not come to know, because A and C are in different ranges. Okay. So in that case, if RTS is sent from A, so what happens? B will not send the CTS, because B is receiving data from C. B is receiving data from C. So it will not send RTS ready to, clear to send. It will never send a clear message. So clear to send message. Once clear to send message is received by A can transmit. So it is a, what we call it as permission mechanism. Permission mechanism. So I can certainly tell. So this goes some way towards addressing the hidden terminal problem. So what happens? The sender sends RTS, a short packet, to the intended receiver. If the packet is received successfully, the receiver responds with another shortest packet. We call it as clear to send, CTS. If CTS is not received, the sender will not send the original data packets. It will not send, because they this mechanism is employed just to avoid collision. Okay, so it will not send the packets. And even though RTS may not have been heard by hidden terminal, the CTS probably will be heard by the hidden terminal. So when CTS is heard by the hidden terminal, oh, it is understood that, B is receiving data from some other hidden node which C cannot hear. C cannot hear. So that is the concept here. And of course, this effectively tell the node within the range of the receiver that they should not send anything for a while. The amount of time the intended transmission is included in RTS and CTS packets. So with the RTS and CTS packets, so RTS and CTS packets are the two packets that are intended for transmitting of data in a Wi-Fi system. So before actually they transmit the original data, so they'll employ a technique called RTS and CTS. RTS is sent by the center, and CTS is sent by your receiver. Receiver will receive RTS message. Once it is free, it is ready to receive, it will send CTS, clear to send packet. So once CTS reaches the sender will transmit the original data packets. So RTS and CTS are what we can say, they are the packets that are meant for establishing the connection safely without collision. Without collision, just to avoid collision. Yes, that is the thing. And after the time plus the small interval has passed, the carrier can assume to be available again, and another node is free to try to send. And of course, two nodes might detect idle link and try to transmit RTS frame at the same time, causes RTS frame to collide each other. RTS frames, if it collides, no problem. So what happens? The data frame is not collide. RTS frame, if it is collide, okay, yeah, both will keep quiet. So it will never reach the receiver, and it will never transmit the data. So since data transmission has not happened, there is no problem. Of course, the sender realizes that collision has happened when they do not receive a CTS frame after a period of time, in which case they will wait for random amount of time before trying to send RTS frame again. So they will send RTS frame again and before sending the CTS. So this is quite important. So and when we look at the frame format, so we have the control bits here, the duration of transmission. Observe here, there are four addresses: address 1, address 2, address 3, and address 4. There are four addresses, and you have sequence control. Sequence control is the one that actually has sequence number of the packets and payload, so where exact data is present, and CRC for error check. So same thing, you can see most of the 802.point frame format, which depicts in the figure, and frame contains the source and destination addresses. So which are of 48-bit long. And remember, 48-bit, whenever I am mentioning it as 48-bit, it is a MAC address, a physical address. Up to 2312 bytes of data and 32-bit CRC can be transmitted in a single frame. Okay. The control fields contain three subfields of interest. 6-bit type field that indicates whether the frame carries the data, or it is carrying an RTS, or it is carrying a CTS. So if it is carrying RTS, it is a different signal you will have in this control. If you have CTS, it will have different control. If it is carrying the data, it is having different. So control field will be holding, three different fields. So three different bit types. So one for data bit, another for RTS bit, another for CTS bit. So that is being used by scanning algorithm, and of course, and a pair of single bit fields called uh, to DS and from DS. That is from which distributed source and from which distributed uh, source. Suppose if you want to send data from one range to another range. For example, so I'm having data at A, and it has to go to D. So A can transmit to B, B can transmit to C, and C can transmit to D. So it has to move from A to D, which is directly not possible. It has to transmit A to B, and B can transmit to C, and C can transmit to D. So because they are in different ranges. So in that case, so it is the first address. So that is the address. We call it as the first two addresses are from the original source and original destination. The next address is from which intermediate source it has come. So to which intermediate the next it has to go. So that is there in address 3 and address 4. So DS, that is distributed system. We call it as distributed system. to distributed system from which to which it has to go, which is described here. And of course, you can see the peculiar thing about 802.11 frame format is that it contains 4 rather than 2 addresses. However, these addresses are interpreted beyond the settings of 2DS and from DS. Okay, bits. So imagine I have just I'll draw some annotations and I'll just let you know how exactly. So imagine you know there are 4 ranges. So 1, 2, 3, and 4 ranges. 4 ranges. So I just label it. This is A. This is A, and this is B, and this is C, and this is a D. A D. Okay. So now observe. Now very clearly observe. So A wants to transmit the data to B, which is directly, there is no link. So what, instead there is an indirect link. A can transmit to B and B can transmit to C and C can transmit to D. So A becomes the address, the original address A. This is A, original address. D is the final address to which it has to reach. In between, so it is sending to B. Yeah, it is sending to B. Yes, it is the B. And from B, it is sending to C. Yes. So from this is from distributed system, and this is 2DS. 2DS. You can see. So it has to transmit like this. So I'm transmitting from A. It has to go to from DS, that is B. Again B, what happens? It is transmitting to C, and from C it is transmitted to D. So this is what you see that is there in the control field specification. This is to account for the possibility that the frame had to be forwarded across the destination system, which would mean that the original sender is not necessarily the same as the most recent transmitted node. Similar reasoning applied to the destination addresses. And of course, you can see in the simplest case, when one node is sending directly to another node, both DS fields bits are set to 0. Address 1 is identified as the target node. Address 2 is identified as a source node, and address 3 and 4 are not there if it is directly transmitting. If it is indirectly transmitting, the intermediate nodes addresses are written here in address 3 and address 4. So if it is direct addressing, this is address 3 and 4 are blank. So that means A can transmit directly to B. Yes. So B address in A address. Yes, both are in the same range. No problem. But if it is forwarded address, suppose you want to transmit via some other range, so definitely that intermediate nodes, it has to be written in address 3 and address 4, which you call it as 2DS, 2 distributed system and from distributed system. So this is the thing. So in the most complex case, both the DS bits are set to 1, indicating that message went from wireless node onto the distributed system and then forwarded from one distributed system to another distributed system, wireless in wireless mode. Yes, it is just like. So when you are forwarding node from one wireless system to another wireless system, so certainly it has to follow the same. It has to follow the same. Now, if both bits are set, so address 1 identifies the ultimate destination, If address 2 identifies the immediate sender, that is one forwards the frame from the distributed system to ultimate destination, and of course address 3 identifies the intermediate destination. See, intermediate sender and intermediate destinations are 2 and 3, and you can see address 4 identifies the original source. So this is original destination. This is original source. So these two are, you know, intermediate source. So intermediate, sources, intermediate source and destinations. So this is what consider as the total and the duration is how long you can transmit, how long this packet can live in this in the Wi-Fi system. So if you specify 10 seconds, within 10 seconds this frame has to reach from source to destination. If it is not reached the destination, automatically the intermediate node will delete this, just to avoid roaming frames. Just to avoid roaming frames, it will delete. So it cannot live beyond this duration time. Any frame, it cannot live beyond this duration time. So duration time is fixed, and which is 10 seconds. So beyond 10 seconds it cannot move further, it cannot live further. So that is one very important concept that you should understand. So that's all for today's class. We discussed hidden node problem. We discussed exposed to node problem. What is the solution? So solution is by sending RTS ready to send and CTS clear to send, two intermediate frames exchange before actually you transmit the original data, actual data. So what happens, that will be that mechanism, CTS and RTS mechanism will avoid collisions, and we can overcome so the problem of a hidden node problem as well as exposed node problem. In the examination, many times they have asked, what is hidden node problem? What is exposed node problem? And so you have to just, work on it. In the next class, we will discuss about distributed system of Wi-Fi, and we'll also discuss Bluetooth 802.15. That is another wireless communication system, and various applications of Bluetooth we'll discuss. Meanwhile, so today, if uh, this class recorded video will be available in this website, and you can also get the study material from this website. So that's all for the day. And before actually I conclude, I have been discussing in the class uh, with all of you to sign into Google Classroom. So what do? You go to Google Classroom. How to go to Google Classroom? You just open your account like this. You just open your account, email. You just open it, and one in the Google Apps, you have a component called Google Classroom. Go to Google Classroom. Once you reach Google Classroom, so you can join. Click on this button. So join. So inside join, I'll give the class ID. I'll give the class ID in the next class. I have not yet created class for you. You can see I have created a Python class. I have created a big data analytics class. Just like I can create a class for you people. And once I give the class, so you all can join to that class where I will do all the announcements, all the assignments can be, given there. All assignments I can track there. So it is just like that. I have been there in one of the classrooms where my teacher is announcing. See, he's announcing. He is announcing a lot of things. My teacher is announcing. Actually, he's my friend. and I just wanted to know. So what are all the announcements he makes? So all the announcements that we make in the classroom is available here. So you can see it's available here. So just like this, we can also create one class, and all of you can join to this classroom. I'll give the classroom code tomorrow. Once classroom code is shared with you, you can join in the class. So that's all for today's class. So have a wonderful day. Happy learning. Thank you. Is there anyone has any doubt? If you have any doubt, please you can ping me in WhatsApp. So that's all for today. We'll meet you with further topics tomorrow. Thank you.